Let's start looking at some applications in business that we can work at using our knowledge of quadratic functions. So first of all, recall the idea of a break-even point. So if you've got a function that tells you the cost of producing some number of units and a function that tells you how much revenue you'll collect for selling some number of units, the break-even point is the number of units when those two are equal, when the cost and the revenue are equal. Another way of saying that is to say that the profit is zero. So if your cost and your revenue are the same, the amount of money coming in and the amount of money going out are equal, then there's no profit and there's no loss. So here's an example. If the total cost of production is given by this function c of x, and the total revenue is described by this function r of x. The units of these functions are dollars, and x represents the number of units sold. We're going to use these functions to figure out the break-even points. So the idea here is if I wanted to know the cost of producing 10 units, say, I'd plug a 10 in for x, wherever I see an x. And if I want to know how much revenue I collect, I'd plug a 10 in to the function r. So if the revenue is greater than the cost, I've made a profit. If it's less, then I've taken a loss. And I want to know when is it equal, so when am I breaking even? So the idea is we want to figure out when these two functions, the cost and the revenue, give us the same output value. So you do that by setting them equal to each other and solving for x. So this is going to be a quadratic equation I can solve. So let's start by writing everything on in standard form. So I'll move the x squared over to the other side by adding x squared to both sides. And then I'll subtract 140x from both sides. And that's how I end up with this equation. And there are several ways to solve that equation. I could use the quadratic formula, or turns out in this case the numbers work out nicely if I factor, because 90 is 20 plus 70, and 1400 is 20 times 70. And I can get this minus sign here by using minus signs here and here. So you'd get the same result if you used the quadratic formula to obtain your solutions for x, but we're going to get our solutions by factoring like this. Either way, we end up with the values 20 and 70. So what does that mean? If I plug either one of these x values in to these two functions, their outputs are the same. So if I produce and sell 20 units, I'll break even. If I produce and sell 70 units, I'll break even. And let's just take a look at a graph to see if we can understand that. So the blue curve that we see here, this is the revenue function. And the red line that's drawn here is a graph of the cost function. So what we can see is at 20 and at 70, these are equal to each other. What's happening in between? Well, the revenue curve is above the cost line. In here, the revenue, the money you're collecting, is greater than your cost of production, which means in this region, you're actually earning a profit. And outside of this region, like over here, your cost is exceeding your revenue, so you're actually taking a loss. And the same thing's happening in this region, which means between the two break-even points of 20 and 70, if you produce and sell a number of units between 20 and 70, you will make some profit in this situation.